This is the Fool the Robot game, powered by what I call the vector neural network. So I wanted to create a hybrid system that uses both rules and neural network because I hoped it would combine the best of both worlds. On one hand, the ability to understand, explain, and tweak that a rules-based system provides, and on the other, the nearly magical insight that a deep neural network provides. The application is a game, which is fun because you get to go head-to-head with the AI, but it also illustrates the point of the project. So the point of the game is to do what's called launching an adversarial attack, or fooling an AI. You do it by modifying an existing character into a new one. Imagine you're modifying a number so you don't have to rewrite a form or something. Here we're modifying an 8 into a 3. It works because the tens of thousands of samples the neural network has seen have taught it that a 3 is not usually drawn that way. And it has no high-level concepts to correct that. At least it didn't until now. So you can see the tracing algorithm can see it's no longer likely an 8, but the neural network holds on to its old biases, if you will. So let's see, did we fool it? Well, there are three voices at the table. There's the human, there's the vector neural network, and then there's the regular neural network. Let's see what they say. Yes. So both the vector neural network and you agree that this is a 3, but the neural network, the old neural network, holds on to its 8 prediction with 99% confidence, despite the fact that we can plainly see that it's a 3. How does it work? Well, the standard neural network part of it just feeds all 784 pixels directly into the neural network. But the vectorizer uses a 5-step process to develop the trace that you saw in the game part. So first, it just generates an outline. Easy enough. Then it takes vertical slices at each point and generates a midpoint or two within each one of those vertical slices. From there, it gets a little more complicated. So each one of those midpoints are connected to all the contiguous ones. And that's done with a multi-part filter that includes a recursive backtracking filter that makes sure that all of these points that are connected should be connected. And all of this happens dynamically. You can watch it change as we modify this, and whether you add or remove pixels. And I think it's done in a pretty good balance. I mean, if it's too sparse and you just avoid all white, then you really have too few contiguous connections to choose from. But if it's very easy for it to spiderweb and create a real mess out of this. So there's a good balance here. And then from there, the tracing algorithm is designed to reduce the number of segments. And then finally, it adds ends to it, and it is the tracing segment alone, along with some of the features that get sent to the neural network. And at any time, you can use the predict button and see the confidence level that either the standard neural network or the vectorized neural network has about a given numeral. And you can do this on the fly as you dynamically make changes. Over the last few days, I've been really integrating the rule-based part of the app with the neural network. So for example, the system determines if a shape is open or closed. But instead of creating a hard and fast rule that concludes 8s and 0s are always closed, which we can look at here and plainly see is not the case, it creates a closed feature. And the neural network can weigh this along with all the others it has about the character, which are not just a series of vaguely connected pixels, but a series of vectors that trace the path of the number. In both these regards, I think this is very much the way a human thinks about this problem. In the weeks I've been tweaking this, I've gotten it to 92, 94% accuracy. But more importantly, what I hope to demonstrate here is that by making a machine learning system more interpretable, explainable, we as developers, as citizens really, can participate in the development of these AI systems and make them not just more accurate, but to reflect our understanding of the world, maybe how we think it should be. And we can do it while retaining all the gains of machine learning.